Let's try this one. In the xy plane, if line K has a negative slope and passes through the point negative 3, S, is the x-intercept of line K positive? We have two statements, right? The slope of line K is negative 3, S is less than 0. Actually, two interesting approaches. One totally algebraic, without having to visualize anything, and one almost entirely geometrical, which requires visualization. So think about it. You have a line with a negative slope. So what is a line on the plane represented with? A linear equation with two variables of the form y equals mx plus b. Telling you that line K has a negative slope means that m is a negative number. And the fact that the line passes through the point means that if you substitute these two coordinates in the original equation of the line, it turns out to be a true equality. So let's do that. You substitute y for s, you have s equals m times x, that is negative 3 times m, plus b. B, not 6, people. So you know that this equality is a true one because of that definition, that that point belongs to the line. And the question is the x-intercept of line K positive? Now, if you've taken, the definition of the intercept seriously, you must remember by now that this is a single formula. This negative b over m, that is the value of the horizontal intercept. The question is whether this is positive, which would be pretty much the same as asking whether b over m is negative, right? So this is the question. B over m negative. Do you remember what happened when you have this kind of inequality hanging around? That a or x over y is less than 0. What does it mean? Remember? What does it mean about the signs of the two quantities? It's basically they're asking you, are b and m of different signs? Because that's what the inequality means. That b over m is less than 0 if they are both real numbers, means that the two numbers have opposite signs, right? So are b and m of different or opposite signs? That's the true question you need to reply to. So let's go, on this question using a purely algebraic approach. You know that the slope of line K is negative 3. So is that of any use? The slope of line K is negative 3. So what is the slope? M. I know that the slope is less than 0. Now they are telling me that it's exactly negative 3. People, with this information, is there any way, any possibility that I could know the value of b? Any? How could I connect m with b? Here there is an interesting relationship, right? S equals negative 3m plus b. So it's an expression that connects m and b. Unfortunately, this depends only on s. Sorry, also on s. That is to say, if from that relationship I would like to establish the value of n, I would first have to know what the value of m is and the value of s is. Unfortunately, s is unknown. I have nothing to say about S. Here, a default assumption is that S is just a real number. That's not enough. With that, I can't establish what the value of B is, let alone the sign. Okay? I don't know the sign. So statement 1 is not sufficient. I don't have sufficient information to tell whether B and M have different signs. What about statement 2? S is less than 0. Oh, this is interesting. Let's take into account just the information above, please. Not statement 1, only this. This is what we know to be certain from the information prior to the question. So I know that S is less than 0. But if this is true, then this expression here, which is equivalent to S, must be negative. If negative 3M plus B is negative, what does it mean about B and M? Notice that this means that B is less than 3M, properties of inequalities. People, can I establish or form the ratio B over M? Yeah, I could do that, right? If I just divided both sides of the inequality by M, the common factor. You divide here by M, I divide here by M, and then I form the ratio which relates to the question. But be careful, what is the sign of N? Do we know? Yeah, we know it's negative. So when you divide by a negative number, remember what needs to happen. B over M would be greater than 3. B over M greater than 3. Right? This has to change because we are dividing by a negative number, a negative factor. So B over M being greater than 3 means that this is positive. Therefore, the answer to the question is a no. B and M have the same sign. They don't have different signs. So we have a unique answer to the question. Correct choice, B. Notice that this, approach simply uses whatever we learned about inequalities, right? Remember that first property of inequalities we discussed? Well, now it's important, right? So this is it. What would be more geometric approach that would require that you try and visualize what the problem describes? So let's see if we can figure this out. Let's take a look at what the first statement means geometrically speaking. If you have like this XY plane, okay, X and Y, and they tell you that the slope of line K is negative 3, and at the same time they are telling you that the point passes through this point. Notice, negative 3, S means that the intersection point must be located, on a vertical line that passes through this position. Any point on that vertical line would have a horizontal coordinate of negative 3. Unfortunately, we don't know S, so S could be anywhere along that vertical line. Now, let's start imagining what would the line K would be, what line K would be like if it crossed, through the point negative 3, S, considering very different values for S. Let's say, for example, that S were a very big positive number. So it were something like here. So if you were to draw a line with a negative slope of negative 3, that means, since it's less than negative 1, that the declination angle must be greater than 45 degrees. So it's a steep line with descending orientation. Perhaps something like this? something like this. So what is the x-intercept? Well, it's positive. And if S were very big, or very, very far upwards with a very big positive value for S, then probably the line could look something like this, right? With an x-intercept that would be clearly positive. But now let's imagine the opposite situation. What would happen if S were a negative value? Nothing forbids that possibility. So we are compelled to consider that. If S were negative, imagine, S being over here. So the intersection point or that crossing point would be in the third quadrant. And a point or a line crossing the third quadrant with a negative slope of -3 would look pretty much like this. Now we see that totally, opposite from the first two cases, the x-intercept would not only be negative, but would be to the left of -3. It would be more negative than -3. So now we clearly see that here we have two answers to the question. The x-intercept could perfectly be both positive or negative. So that is why this is not sufficient. Here, these cases represent a yes for an answer to the question. This one represents a no, right? So we've visualized what the first statement means, geometrically speaking. What about the second? Can we truly visualize the second statement? Well, the second statement simply says S is less than 0, meaning that the point where this line K crosses, is a point located in the third quadrant. Now let's try and visualize the third quadrant like this. Here's the y-axis, the x-axis, the origin. We know that the crossing point for this line has these coordinates, -3 and S. And if S is negative, that means that the point could be on the vertical line that passes through this position -3 and any possible vertical negative position. So, for example, this one. Make a line cross that point with a steep negative slope. So it would look like this. Right? A negative slope would always determine an x-intercept that will always be, always. Now, here we don't know really how negative is the slope. Remember, we don't need to look at the statement 1. Statement 1 said that the negative slope was -3, but with information of statement 2 alone, we don't really know how negative K could be. So let's consider different degrees of negativity, all right? Imagine a very negative value of K. Let's imagine a not so negative value of K, a softer, but crossing through the same point. So it means when the slope becomes softer, less negative, what happens is simply that the negative the x-intercept of the line goes further and further to the left of -3. So no matter how you change, even if you make the slope a very, very negative, something like, for example, this, very, very vertical. Even in that case, the x-intercept will always have to be to the left of -3. In other words, with these different cases, we can visualize that the x-intercept has to be less than -3. So this confirms that the x-intercept will never be positive. The answer to the question is a no, and therefore we have sufficiency with the statement 2 alone. Which way do you like most? Which way do you like better? Just purely algebraic or more geometrically oriented? Truth is, people, If you practice this kind of question and get, a faster sense of what is going on in geometry terms, then you could actually be solving these questions faster and faster than taking just the purely algebraic approach. Yeah, algebra is useful, but if you can get to visualize cases like this, then obviously you will be performing faster.